Afternoon everyone. Today we are going to discuss about the Booth's algorithm. In the previous class, we have seen how we can multiply two positive integers using sequential multiplier. Today we are going to discuss if we have to perform the multiplication for the signed numbers, how can we perform using Booth's algorithm. So, the signed multiplication means the multiplicand can be negative or multiplier could be negative. So for both of this Booth's algorithm works. So now when we are trying to perform the multiplication, Booth uses an encoding method. Say for example, you want to multiply a given number by 9. So say for example, a number like this is given to you and you're supposed to multiply by 9. So instead, what is the trick? You just multiply this number by 10. Okay, so you will be getting 12350 and subtract it once. Correct? So you will be getting the product 1235 into 9. So the same concept is followed in Booth's, but we don't have 9, 10 and all that. You'll be using zeros and ones in Booth's algorithm. Okay. So what he does in this recoding is for the 2 bits, that is you have, if I take 2 bits, okay, so what will be the recoded pair is based on this table. Okay, when you're recoding from 0 to 0, it is 0 into m. When you are recoding from 1 to 0, it is plus 1 into m. And when you are recoding from 0 to 1, it is minus 1 into m, and 1 to 1 is 0 into m. That is, see, when you have a stream of zeros and when you have a stream of 1, say like this, you have some pairs of some numbers. So when you recode this, see, 0 to 0 is 0, 0 to 1 is minus 1, 1 to 1 is 0, 1 to 1 is 0, 1 to 1 is 0. So 1 to 0 is plus 1. So 0 to 1 is minus 1. Then you have 0, 0, 0, 0, 0, 0, 0. 1 to 0 is plus 1. So here wherever you have the zeros, it is like everything is 0. So the main aim here is in Booth's algorithm is when you have continuous stream of ones, it will be recoded as 0. Okay, so that is the advantage. So here first we will see for a negative multiplicand. As I told you, Booth's algorithm works for both positive and negative numbers, and also the multiplier or multiplicand could be a negative number. So minus 6 into 6, minus 6 is your multiplicand. Okay, your plus 6 is your multiplier. So now I have to always remember one thing, you're supposed to recode the multiplier. So when I recode the multiplier, what is the multiplier? Multiplier is 0, 1, 1, 0. So when I'll be pairing, right? So I will add an implied 0 at the LSB. Then I'll start recoding. 6 is my multiplier. Okay, so in binary it is 0, 1, 1, 0. So 0 to 0, the recoding, what I told you in the previous table, you have to just go through that. 0 to 1 is minus 1, 1 to 1 is 0, 1 to 0 is plus 1. So these are my recoded bits. So now I have to perform the multiplication. What is my multiplicand? Multiplicand is minus 6. So how do I write minus 6 is? This is plus 6, correct? So now minus 6 is converting this to 1's complement, then to 2's complement. So this is 1's complement. If I add 1, then I'll get 2's complement. 1 plus 1 is 0. Carry 1, 0, 1. So I got 1, 0, 1, 0. This is equivalent to minus 6. So minus 6 into, I have to multiply with this recoded bits. What are the recoded bits? It is plus 1, 0, minus 1 and 0. So now I have to multiply minus 6 with plus 6. So minus 6, as you all know, it is written in your 2's complement in this way. So 1010 is my multiplicand. Multiplicand and multiplier. Recoded bits. How did we recode? We recoded 6 and I added an implied 0. So I got 0. For this I got minus 1. For this I got 0. For this I got plus 1. So my recoded bits are 0, minus 1, 0 and a plus 1. So now I have to multiply with each bit of this. So 0 into this would give me 0. Next I have to multiply with minus 1. When I am multiplying something with minus 1, it should be, it is as good as taking 2's complement of multiplicand. If I take 2's complement of the multiplicand 1010, I'll get it as 0 1 0 1. Add 1 to this. Okay, it is this. So with a shift of 1 bit I will be writing this. Then it is multiply by 0. Again I have to shift 1 bit with respect to this. So it will be zeros. Okay. Next I have to multiply with plus 1. Plus 1 means write the multiplicand as it is, right? So 0 1 0 1. Okay. So I got this. But here, since this are for your negative numbers, you have to do a sign extension, and remember always your product will be 2 times your 2 times the number of bits in your multiplicand. So here I have 4 bits, so you will have 8. So 2 into n. So sign extension is whatever is your MSB, extend by 1 bit. So here together I will be getting 8 bits. Here it is 0, so I will extend by 0. Here it is 0, your MSB is 0, so I am extending by 0. So here also it is 0. Now finally add all this 0, 0, 1, 1, 1, 0, 1, 1. I got this number. Now I don't know whether this is really right. What I should have got, actually I should have got minus 6 into plus 6 is minus 36. I don't know whether it is right. I'm just converting this back into 2's complement and checking whether my answer is right. So 1 plus 1 0, 1 plus 1 0, carry 1, 1. Okay. Now just check. I have got 0 0 1 0 0 1 0 0. So what is this? This is 4. 4 plus 32. 32 plus 4 is 36. So this answer what I have got is right. This is minus 36. So this is how you will be recoding your numbers, and you will be multiplying with the recoded bits, the multiplicand, and finally all these whatever you have got are your partial products. Partial products. Okay. So next we will see when your multiplier is a negative number. So when your multiplier is a negative number, what should you do? So the numbers given to us are minus 6 and minus 2. So minus 6 is 1010. This is my multiplicand, and 2. 2 is what? 0, 0, 1, 0. That is, this is plus 2. If I convert this minus 2, I'll get this. So this is minus 2, which is my multiplier. Now we are supposed to recode the bits. If I have to recode, always recode your multiplier. Okay, add an implied 0. 0 to 0 is 0. 0 to 1 minus 1. 1 to 0 is 0. 1 to, I'm sorry, 1 to 1 is 0. 1 to 1 is also 0. So it is 0 0 minus 1 0. So this is my recoded bits. Now we will multiply with this recoded bits. Multiplicand is 1 0 1 0. So this is nothing but your m. So if I have to get plus the 2's complement of this, that is minus m, then again convert this to your 2's complement. So I am getting 0 1 1 0 is my minus m. So now I have to multiply this with the recoded bits 0 minus 1 0 0. So when I multiply with 0, obviously everything is 0. Then when I multiply with minus 1, it's as good as I have to take the 2's complement of the multiplicand. 2's complement of the multiplicand is minus m. Then all others are zeros. With a 1 bit shift, you are supposed to. Okay, this is 1 bit. But I told you your product should be equal to 8 bits. Here I have 7 bits, so I'll do a sign extension. This is 0. This is 0. This is also 0. This is also 0. Okay. So now is equivalent to 8 bits. So 0. When I sum up all these products, getting 1, 1, 0. So I'm getting 1, 1, 0, 0. And you can see the sign bit here is also 0. So it is 12 what I'm getting. So what we had done, we had taken minus 6 into minus 2, which is plus 12. So we are getting 12. So this is the right answer. So this is how you will be using Booth's algorithm. Okay, for signed integers. Okay, hope you all have understood. Thank you all.